Okay, welcome to all. In this video, I am going to explain what is the working of timer or counter module in 8051 and what are the different registers associated with it, how to configure them to use it in different modes. So first of all, what is a timer or counter? The main purpose of timer is to generate required amount of delays precisely. And the purpose of counter is to count the number of events or pulses that are occurring at a pin. When operating as a timer, it counts the internal pulses coming to the timer block. When operating as a counter, it counts the pulses that are occurring at external pin of the microcontroller. In both the cases, what it does is it counts the pulses, and the value of the counter will be incremented for every clock pulse it is receiving. If the clock pulses are from internal source or the clock pulse that is divided by 12 of the oscillator frequency you have connected, then it is a timer. Or if the pulses that are coming to that module is through a pin external to the 8051 microcontroller, then we call it as a counter. In both the cases, for every pulse, the value of the counter will be incremented. That is the basic. Okay. Now, how does it work? As we mentioned earlier, counter or timer will be incremented for every clock pulse it is receiving. So internally, it will have 16 bits or two memory locations, each of 8 bits. For every clock pulse it is receiving, the value of these registers will be incremented. If the source is from the oscillator, we call it as a timer. If the source is from a pin, we call it as a counter. Okay. Whenever this counter value is overflown, means all bits becomes ones. Then for the next clock pulse, it again starts counting from 0. That event we call it as overflow. So when overflow is occurred, this TF bit becomes 1. So that is the basic operation of timer. So what are all these other representations and everything we will see after seeing what are the registers associated with it. But the basic operation is there are two registers. For that, clock pulses are applied. For every clock pulse, it is incrementing. Once that registers overflow, TF bit will be set. That is the working of general timer or counter module. So what are the different registers that are associated with the timer? So there are 4 registers: T mod, T con, TH, and TL. So TH and TL, there is no special operation for this 2 registers. For every clock pulse it is receiving, these values will be incremented, these 2 registers. Then in order to control the operation of timer in different modes, these 2 registers are to be used. One is T mod, which defines in which mode you are operating the timer. T con is how you are controlling the timer, whether to start or stop, everything. How we are controlling. This register, T con register, will be used. Okay. Each bit have specific significance in T mod and T con registers. What are those? We'll see one by one. TH and TL, as we already said, for every clock pulse it is receiving, it will be incremented. So first, TL register will be incremented from 0, 0, 0, 0, 8 bits of zeros to 8 bits of ones. For the next clock pulse, again it starts from 0 and TH will be incremented. And again, once it is overflown, again TH will be incremented. And like that, if this TH and TL both becomes 1, and for the next clock pulse, again, this TH becomes 0 and TL also becomes 0. That we are calling it as overflow condition. Okay. So TH 8 bits are there, TL 8 bits are there. Clock is applied. So first TL will be incremented. Once it is overflown, TH will be incremented. Once both are completed, TF will be updated. T mod. So what do you mean by T mod? As we said earlier, the timer module is counting the pulses. But whether it is counting the pulses coming from the oscillator or the pin, we need to decide. This will be done by using a bit in this T mod register, C by T bar. Whenever there is a bar above any representation, it means active low. T bar means T will be activated whenever it is low. This bit is low. If this bit is high, it will act like a counter. Whenever this bit is low, this timer 1 will be acting like a timer. Okay. Next, gate. What is this gate? We'll see during block diagram representation. Okay. And this T mod register, there are two more bits, M1, M0, which will decide in which mode we are operating the timer. So as we seen earlier, this TH is having 8 bits and TL is also having 8 bits. Out of these 16 bits, how many bits you are using for counting? This will be decided by modes. So there are 4 possible modes. 0, 1, 2, 3. If you are selecting mod 0, means 0 mode, then in TL only 5 bits will be used, and in TH 13 bits will be, 8 bits will be used. So 8 plus 5, 13. Or one 8-bit counter is there, which is multiplied by 5-bit value. For example, here 8 bits are used. So it can count from 0 to F. Okay. This TL, here we can only adjust a value between 5 zeros to 5 ones. Between that, you can have any value. Okay. And these total count will be counted this much number of times. This into this, which is nothing but scaling. So that's why it is an 8-bit counter with 5-bit prescale. And mode 1, 16-bit timer or counter. So entire TL 8 bits and TH 8 bits. Both 16 bits are used for either timer or counter operation. That is mode 1. Mode 2. Mode 2 means whenever you are using this TH and TL registers, only 8 bits are used for counting. You will load the value in TL and TH. Once timer overflows, in general, what happens? It again starts from 0. But if you operate in 8-bit auto reload mode or mode 2, whenever all bits becomes ones, for the next clock pulse, whatever value you stored in TH, this will be automatically loaded in TL and starts counting from that particular value instead of 0. That mode we are calling it as 8-bit auto reload mode. And third mode is split mode. Split mode means this will be used as separate counter or timer, and this will be used as separate timer or counter. The detailed operation will be explained with the help of block diagram. Okay. So T mod, this is used to control the mode of operation, means either timer or counter and in which mode. So for mode selection 2 bits, timer or counter 1 bit, and gate, whether the timer operation is to be controlled externally also, means if the pin is high, then only this timer will be operated. If the pin is low, this timer will not be operated. Okay. So that control bit is here. So MSB 4 bits for timer 1, LSB 4 bits for timer 0. Okay. Control. So till now we have configured in which mode it is to be operated and how many bits are to be used. Is it auto reload or manually reload? or split mode. All these things we have configured, which is mode of operation we have decided. Now to control the timer, there is another register TCON. And out of these 8 bits, the LSB 4 bits are meant for interrupt operation. There is nothing to do with timer. Only MSB 4 bits are meant for controlling the timer. So TF, TR. So timer run, timer overflow. So for timer 0, 2 bits. For timer 1, 2 bits. So if your timer has to count the pulses, this TR bit must be 1. If this TR bit is 0, even if you give clock pulses, the timer will not increment the value. Okay. So for timer 0 to operate, this TR0 must be 1. For timer 1 to be operated, this TR bit must be 1. Okay. So this is to be manually made, means this is to be done by the software. Okay. So in whenever a bit is to be programmed by the user, it will be specified as software, means it is to be set or reset by the software. Okay. If the processor itself is doing that, then it is set or reset by the hardware. Okay. So TF0, TF1, timer overflow. So whenever all bits are becoming 1, again it is starting from 0. At that instant, at that event is happening, we will not do anything. The processor itself will make this pin high. So that's why it is called hardware. Okay, set by hardware or cleared by, timer 1 overflow, set by hardware when timer or counter 1 overflows. Okay, cleared by hardware as the processor vector to the interrupt service. ఒకవేళ if we use timer for interrupts, then it will be automatically made to 0. But if you are not using interrupt, you need to make it 0. Okay. Similarly for timer 0. So in order to run the timer, this bit is controlled. In order to monitor whether that event, overflow event is occurred or not, we need to monitor these 2 bits. Okay. So when this event is occurred, we need to do something. Then we will write a condition while this bit is 0, we need to wait. Whenever this bit becomes 1, the required delay has been over. We need to write whatever instructions that are required. Okay. And these for interrupts. So there are INT0, INT1. External interrupts are there. So when to consider that pin has received an interrupt, whether it is edge triggered or level triggered, interrupted type, IT. So for INT0, IT0, for INT1, IT1. Okay. So IT1, interrupt 1 type control. Set or clear by the software, means manually we need to do to specify falling edge or low level triggering external interrupt. Okay. Low level or falling edge, which will be set by IT bit. Okay. Similarly for interrupt 1, is it level triggering or edge trigger? It will be made by making it either 1 or 0. Whenever that interrupt is going on, this IE1 bit will become high. When that interrupt is over, this will be automatically made equal to 0. We will not do anything. It will be automatically set and it will be automatically reset. Okay. So if you observe, external interrupt 1 edge flag set by CPU when external interrupt edge high to low transition is detected, cleared by CPU when interrupt is processed. So interrupt will be identified. Once identified, this becomes high. Once that interrupt work is over, so whatever program we have written for that interrupt, if that program is over, automatically CPU itself will clear this bit. Okay. So that is the operation of TCON register or the functionality of TCON register. Now different modes. Pictorially, how we can explain. So mode 0, we already seen that it is an 8-bit counter with 5-bit prescaler. So this is the maximum count. This into this is the maximum count it can measure the pulses. So pulses are coming, but in order to increment or decrement, which is controlling, TR bit is controlling. Okay. So this TR bit is 1, then only this switch will be closed. If TR bit is 0, this switch will be open. This is an AND gate. So if this is 0, obviously it will be open. If this is 1, the other input also must be 1. If gate is enabled. If gate is enabled, this as well as this, both pins must be such that for this AND gate, there must be 1. For example, if you say gate bit is 1, 1 means you are enabling gate. There is a NOT gate. So 1, it becomes 0. So 0, 0. This input is 0. Whenever this pin is also 0, output will become 0 and get output 0. If this is 1, this is an OR gate. So either this or this, any one should be high so that this TR1 is applied for this. Okay. If you make this gate bit 0, not get applied. So 0 becomes 1. So for OR gate, it is not necessary whether it is 1 or 0. This is always high. Okay. So when gate bit is set, it will look for this pin status. If this gate bit is low, it will neglect the status of this pin. So the clock pulses to be applied for this timer will be controlled by TR1 alone. If gate is enabled, this clock pulse will be controlled by TR1 as well as interrupt pin. Okay. So if you observe one more important thing, the oscillator pulses will not be applied directly to the timer. The frequency at which the pulses are coming to the timer will be oscillator divided by 12. The frequency at which the timer module is receiving the pulses. Okay. This is regarding mode 0. Mode 1, operation remains same. The only difference is here TL is also 8 bits. Okay. Whenever these all bits becomes ones, TF bit will be set. If interrupt is activated, it will go to interrupt. Otherwise, it will not go. Okay. Mode 2, 8-bit auto reload mode. So instead of 16 bits, 8 bits are only meant for counting. The other 8 bits, TH bits, are meant to store a particular value, which is to be loaded every time once after overflow is observed. Suppose if you are loading a value of 90 here, the timer overflown. Overflown means all bit becomes ones. For the next clock pulse, it has to start from 0. Instead of starting from 0, this 90 will be loaded here and starts counting from 90, 91, 92 like that. Okay. So these 8 bits will be automatically reloaded. That's why it is called 8-bit auto reload. So this counter timer bit, TR bit, gate bit, these will not be changed. These operation remains same. The only difference is how we are using this TH and TL. In mode 0, 5 bits and 8 bits are used. In mode 1, 8 bits and 8 bits are used. In mode 2, 8 bits with auto reload is used. Okay. Similarly, in mode 3, split mode. For timer 0 only, the lower 8 bits, we can operate it as either a timer or a counter with gate signal enabled, just like normal 8-bit time. Okay. The control can be done by using TR0 to start or stop the operation. And to monitor, we are using TF0. And the TH0, it is belonging to timer module 0, but it is controlled by TR1. And whenever overflow occurs, TF1 will be set. Okay. There is no choice for counter operation. Okay. So timer 0, lower 8 bits will be used as either counter or timer, and higher 8 bits can be used as a timer. This mode we call it as split mode of operation. Okay. These are the three modes. Now, how to program a timer? What is the procedure to be followed? First, we need to decide how many bits we are going to use and in which mode you are going to operate. Means either you want 16 bits or you want 13 bits or 8-bit auto reload or split mode. We need to decide. And also we need to decide whether gate is to be enabled or disabled. Based on that, these bits are to be set. Suppose we want 16-bit timer gate disabled. So gate disabled, this bit must be 0. Timer, this bit must be 0. 16-bit, 16-bit means mode 1, 0, 1. So 0, 0, 1, 0. So 2 is to be placed. If you are using timer 0 also, correspondingly the values are to be loaded here. Otherwise, it is irrespective. Okay. So like that, we need to decide what is the value to be loaded in TMOD register. Then you need to load the TH and TL registers with initial count value. Suppose if you are not loading anything, by default the counting starts from 0. And after receiving the mode of, depending on the mode, suppose if you are using 16-bit mode, after receiving 65535 pulses, all bits becomes ones. And after that, TF bit will be set. So timer is counting 65535 pulses. We want only 50 pulses count. Then instead of starting from 0, we need to load 65535 minus 50. That value is to be loaded. Okay, 65535 minus 50 plus 1, because at the end also it receives one pulse. After all bits becomes 1, it receives next pulse and then TF bit will be set. So the value to be loaded in TH and TL registers will be the maximum count it can count minus the required amount of pulses to be counted plus 1. Okay. So we fixed the mode of operation and we fixed the value of count that is required. Then we need to start the timer. So if you are using timer 0, TR0 equal to 1. If you are using timer 1, TR1 equal to 1. So once you make this bit high, TR bit high, the timer will receive the pulses and it starts counting. And we need to wait until TF bit is set. So keep monitoring the timer flag TFX. So what is the instruction for that? While TFX equal to 0. So until the maximum count is reached, this condition will be satisfied and the control will be here only. Once overflow occurred, TFX becomes 1 and control comes out of the loop. So required delay is over. So we need to stop the timer. And for the next time, if you are not doing anything, what happens? Again, count starts from 0. But we want only X number of counts. So again, we need to load these values, TH and TL, and we need to clear the TF flag. So once overflow occurred, it has become 1. So unless you make it 0, it is not possible to detect again. Otherwise, what happens? TFX is still 1. As soon as you enter the value and you execute this condition, while TFX equal to 0, it will be failed at the initial state only. So after required delay is over, you need to stop the timer, clear the flag, and load the required values of TH and TL, and again repeat the process. See, load the values, go to step 2, a value on what is that value we will be loading, and again starting the time. So this is the general procedure for operation of timer module. Thanks for watching.